Assalamualaikum and good evening. So my name is Muhammad Hidayat bin HASLIN. So this is our presentation for fundamentals of electrical engineering lab project. So for our project, we decide to make the project based on the third choice, which is the output voltage is 12 volt positive 12 volt DC, positive 9 volt DC, and positive 5 volt DC. We will be using an IC regulator 7812, 7809 and 7805. So as we know, power supply is a hardware component that supplies power to an electrical device. So a DC power supply is a hardware circuitry which converts the AC supply into DC. So IC regulator 78112, 7809 and 7805 is a voltage regulator type, which self-contained fixed linear voltage regulator integrated circuit. So for this circuit, we will connect our components using a soldering process, and the components were soldered, and all these components, the IC regulator, the capacitor, and things like that will be connected on the straight board. So soldering process is a process which we combine the components using a heated tin and soldering equipment. Okay, so for our project objective, the first one is to design a AC to DC full wave rectifier circuit with voltage regulators. Then to observe and measure the output voltage and waveform of AC to DC circuit with voltage regulator. And the third one is to measure and observe the output voltage from the voltage regulator. So this is the component we use for our project. The first one is the 3 voltage regulator, the 12 volt, the positive 12 volt regulator, positive 9 volt, and positive 5 volt regulators, which will use to regulate the DC voltage from the circuit. Then the second one is the step down transformer, which will lower the incoming 240 volt voltage, and it will lower the voltage to 12 volt AC voltage. And then we use 4 diodes, which will then be used to form a full wave rectifier from these 4 diodes. Then number 4 is capacitors. We use one 2200 microfarad capacitor and 3 220 microfarad capacitors. So for the main function of the capacitor is first to store and release electricity in circuit, and also to smooth out the output DC voltages in our circuit. And finally, cables. These cables were used to connect the components on the straight board. So these cables were soldered from components to components on our straight board. Then next, okay. For the first step for our project, we use the circuit diagram. We do a simulation to ensure that our connection is correct and can work in the real components. So first we do the simulation on multi-sim software. So this is our circuit. So as you can see, this is the step down transformer from 240 volt to 12 volt, and then the AC voltage will pass through a full wave rectifier here, and then will pass through a capacitor, and then after that it will pass through the voltage regulator circuit here, and then the output is connected to the output. So this is the results on the waveform of multisim. So the first one is the output from the 78112, so which will give us the 12 volt output, and the second one is the output from 7809 voltage regulator, which gives us the output of 9 volt, positive 9 volt, and then finally is LM 7805 voltage regulator, which gives us the output of positive 5 volt. Okay, then for breadboard prototyping will be explained by my friend. Okay, thank you.
Hello, Assalamualaikum warahmatullahi wabarakatuh. My name Muhammad NAJMI bin Abdul Shukur. My ID FB19011. So today I would like to present the process that we do after we process multi-sim simulation that my friends Hidayat present. So for breadboard prototyping, we assemble the component that we use, which is a diode, and then we use capacitor, 220 farad, and then from the breadboard prototyping, we get the output from ICLM7805 is output voltage. As you can see on the picture, 05.239 voltage that we get from ICLM7805, and from ICLM 7809 we get output 7.186, and for ICLM7812 we get output voltage is 11.203. So after we get the value, we can continue to our final circuit board. On our final circuit board and on and our product, you can see we have output to power supply, AC power supply, and then have a ground port, plus 12 volt port, 9 volt port, and 5 volt port. And on the our box, you can see our transformer that we use to step down to 12 volt. And this one is we do a soldering process to we solder the component to our strip board, and as you can see the result on the slide. So on our waveform, you can see this waveform get from step down transformer. This one get from the step down transformer in AC current, and will go through to full wave rectifier, as you can see on the graph on the slide. This one is after we the AC power supply go to full wave rectifier, and then after that from that we go through to capacitor and voltage regulator circuit. We can see the steady DC voltage on the picture. So I will demo our project. I will demonstrate our project. So firstly, we plug in the power supply, AC power supply, and then the AC power supply we go to transformers to step down to 12 volt, and after that we test with output 5 volt, and input already connect to 5 volt. And you can see on our oscilloscope will get the output 5.03 volt. So we test to on 9 volt output. 9 volt. So this port for 5 volt, 9 volt, and 12 volt, and ground. So after we measure, we get the output 9.25 volt, as you can see on video. So it's connected to 9 volt port, and connect to ground. After that, we test to 12 volt port. Alright, so the output on oscilloscope 12.1 volt. You can see 12.1 volt. Alright. So for lastly, our project finally done with success, and all the objective that we need get from this project. So thank you. That's all from us. Thank you.